lot to it. The liver is a little bit more involved in terms of the anatomy of that liver. Okay, so we're gonna spend some time with that. Do not forget the gallbladder, which is the liver's buddy. Not much about that, other than it's source body, okay? Then we have to do the large intestine. And by now, most of your stuff should have already been fully digested. So, for your post, those of you who are just coming in, if you are wondering where should your post end, the last place should be the small intestine. The last place should be the small intestine. Make sure that you put the contributions of the pancreas and the gallbladder, if applicable, right when you're talking about the small intestine, because pancreas and the gallbladder are going to contribute directly to whatever is in the small intestine. So if you're wondering when to mention them, they should be mentioned when you talk about the food being in the small intestine. That's super, super important, okay? Then from the large intestine, we're gonna finish up with the rectum and the anal canal, or the anus, okay? So that's the rest for our digestive. And then we've got the kidney, and we've got the urinary system. So for urinary system, these are our goals. Of course, there's the overview. The overview is, okay, the overview. We're not going to spend a lot of time on that overview because we want to go straight into the anatomy. And with that anatomy, we're going to introduce all of the components of the urinary system, all of the components, but we're going to specifically focus on the main filtering organ of the urinary system, which is going to be our kidney. When we talk about the kidney, we have to talk about its functional unit. That functional unit is called the nephron, okay? So when you talk about the kidney, you've got to talk about the nephron. And even if you might have seen it in another class, okay, for many of us in this room, the kidney is new. So please be considerate of that, okay? We're all coming from different levels. We're all coming from different backgrounds, okay? A nephron is the microscopic repeating unit, the functional unit of the kidney. And then from the kidney, all we need to do is we need to make urine from that, and then we got to transport that urine, and we got to store that urine, and we got to get rid of that urine. So transport, storage, and excretion. That's going to be achieved by the following organs. The ureter is going to transport it. The urinary bladder is not going to form it, it's going to store it. Okay, so the kidney forms it, the ureter transports it, the urinary bladder stores it, and the urethra excretes it. So first we have to form urine, we got to transport urine, we got to store urine, and then we have to excrete the urine. So that's your big overview. We will spend most of the time on this guy, on the nephron. That nephron, I'm going to put in parentheses or a little bracket right next to it. I want you to think of this number. 4 parts plus 1. 4 parts plus 1. Okay, so there are going to be 4 separate parts to that nephron plus 1. What I mean by the plus 1, it is an essential part that the nephron will lead into, even though technically it's not part of the nephron. Right? So that's our big picture. And these parts you should have already filled in from last time. You should have filled in from last time. These are the monomers that we want to ultimately break our macromolecules to. Okay? And so if you weren't here last time or you didn't get this, make sure that you get that from somebody who's supposed to be there. Right? We left in the small intestine. We already talked about this, the idea of what are the villi versus the microvilli. Okay? So with the small intestine, we had the 3 regions, the duodenum, the jejunum, and the ileum. Specifically into the duodenum is where we are going to be putting in those secretions from the pancreas and the gallbladder. And if you don't have a gallbladder, it would be coming directly from the liver. Okay? Moving on from here, okay? Know the difference between what is a villus versus what are microvilli. Each of these finger-like projections, individually, that is a villus. The microvilli exists on the apical surface of every single cell that makes up the mucosa of that villus. And so if we looked histologically, remember we were looking at histologically, we zoomed in on just the simple columnar. Each of those simple columnar cells have microvilli on the apical surface. Does that make sense? Okay, so the microvilli is also known as the brush border. So everyone in your digestive journey, you gotta tell me brush border enzymes. Because brush border enzymes, there is at least one for every single one of those three. This is going to be an essential part of those 5 points. You have to mention that there were brush border enzymes. Carbohydrates had 3. Proteins, we're going to call them peptidases. Okay, so for the proteins, if you're doing the protein journey, this is the name of your brush border enzymes. We're going to just lump them into one group. Intestinal peptidases. And if you are doing the journey of fats, these are your brush border enzymes. Intestinal lipase. This is for lipid, that is for protein, and if you're doing carbohydrate, those were the 3. The 3 that I mentioned last time. Maltase, sucrase, and lactase. Okay, again, where do these enzymes come from? Do they come from the gallbladder, the pancreas, or neither? Gallbladder, pancreas, or neither? Where did those enzymes come from? This is also an essential part of your post.
They're built in.
They're built in. What does it mean by built in? They are part of the small intestine. They're called brush border enzymes because they literally are tethered to the microvilli. So that part is really important for your post. All right. So this is really the only mention of hormones apart than what we were talking about in the stomach with gastrin. This is the only other mention of hormones. So when the chyme enters the small intestine, the enteroendocrine cells are going to release hormones into the blood, which is by definition what the hormones do. And what those hormones are going to do, they're going to stimulate the pancreas to secrete pancreatic juice and the gallbladder to release bile into the common bile duct. Both of those are going to be delivered into this common space called the sphincter of Oddi. And that sphincter of Oddi leads directly into that duodenum. So in your post, you should include that. Okay. The pancreas and digestion, and then the liver and digestion. The pancreas is really the only gland, or it's the main gland, that has both endocrine and exocrine functions. This is endocrine and digestive systems in one. So know what the endocrine part is doing, know what the exocrine part is doing. Know what are the names of the cells of the endocrine part and the name of the cells of the exocrine part. That is our pancreas. And so exocrine is 90%, that's the digestive part. When it comes to the exocrine part, you've got your acinar cells and you have your duct cells. Your acinar cells are the ones that are going to secrete pancreatic enzymes to digest our macromolecules. What are the pancreatic enzymes? Okay, I'm going to write that on this side. Those were the brush border on that list. Pancreatic enzymes, we have to have one for every single macromolecule, so make sure in your post you include a pancreatic enzyme in there too, because we've got one for everything. Okay. Which macromolecule is that one for? Pancreatic amylase. Is it for carbohydrate, protein, or fats? This is for your carbs. Anytime you see amylase, you should be thinking carbs. Okay, next one. Who is that for?
Fats.
That's for fats. The last one, there's several enzymes going to be from the pancreas that are for proteins. Not gonna go over all of them. I will accept the following. Pancreatic proteases or peptidases. That's a general term for enzymes that break down proteins. So if you're doing the digestion journey of protein, these are your two focuses. Something happens to that protein in the stomach with an enzyme there. What's the enzyme that breaks down protein in the stomach? What is it, everybody? I want to hear everyone say it.
Pepsin.
Pepsin, thank you. Okay, cool. Just want to make sure you guys are set. That's all. Does pepsin break down starches? Lipids? No. Okay. In the stomach, if you're doing journey of lipids, you should mention gastric lipase. But in terms of starches, there's nothing in the stomach for that. Do the carbs still need to pass through the stomach in your post? Yes. Even if there's no digestion of it, it has to go through it anyway. So you make sure you include that. And so these are the pancreatic enzymes that the ACE in our cells are going to make. So we combine that with what's going on the brush border, and that's how we can get all the way down to our monomers. Okay? So with the other accessory organ, okay, that's the liver. This one, I want you to kind of go on your own. This is just the nature of bile and what's in it. But most importantly, just know that the liver makes the bile and the gallbladder stores the bile. But I don't want to go into that much all of the processes, okay, what the bile actually does. It does a lot of things. So just study that for the final exam. Don't worry about the functions all too much with the final practical, okay? What bile will do is emulsify fats. For the practical, I want you to know that function. You would capture it into just one line. That is this emulsifies fats. Emulsifies fats has to go before breakdown. So let me repeat that. Emulsifying fats has to go before the breakdown. Emulsification is not digestion. Emulsification is not chemical digestion. So if you're doing the fat journey, just as an FYI, mention bile first. Then you can talk about pancreatic lipase. Then lastly, you should be talking about intestinal lipase. Does that make sense? Okay. For lipids also, I said at the beginning there's lingual lipase and there's gastric lipase. Those two enzymes do not need bile. So when are we talking about bile? Not until we get into the small intestine. That's when we start talking about bile. I still have student hours today. If anybody wants to come by, we could always use more people. Okay, so if there's like 8 people who regularly come, let's fill up the whole room. I know we get really noisy. Surprised we haven't gotten in trouble yet.
There's a possibility that might get changed next year, so, you know.
Well, I'm not teaching you this year.
What I mean is that they're probably gonna switch us to a room that's actually isolated.
Yes, I think that would be a great idea.
That's what's
because
possibly
it's
gonna happen.
Really, yeah, hard for us to talk out loud. But anyways, come to student hours, okay, if any of this is fuzzy to you. For gross anatomy of the liver, this is pretty much what we went over in lab, so I'm going to skip that. I'm gonna move straight to this. This, we didn't go over in lab, but I would like you to know for the lecture final. Okay, blood versus bile, they are not the same thing. Anything in green refers to anything that bile is gonna be going through. Anything in red, those are your traditional oxygen-rich blood-carrying arteries. Anything in blue, those are your traditional usual veins. And then you have the weird one that is in purple. That's the hepatic portal vein. You guys remember this from circulatory? Okay, so let's see where it all comes together, right? If we were to think of the liver and look at it histologically, this is what you are going to get. Okay, microscopic anatomy. Each of these little repeating units, those are what are called lobules. This you should be able to identify histologically. It may not look nice like this in terms of a pattern, but what you are looking for, you're looking for the presence those little holes in the center of what looks like raw ground beef. And that hole in the center, that's what we're gonna call the central vein. So here's the central vein right here. Eventually from that central vein, that's going to take us to the hepatic veins and then finally out of the liver and back into the inferior vena cava. That's where we're trying to go. However, we need to think about where the hepatic portal vein comes in with all of this. First off, where did the hepatic portal vein come from? There's a difference. There are hepatic veins and there's the hepatic portal vein. Where did the hepatic portal vein come from? The stomach and the intestines. The hepatic portal vein is going to go from those areas and bring blood from those areas and bring that into the liver. So before whatever that blood is, before that blood ends up in the central vein, it has to go to the hepatic portal vein first. And so you have hepatic arteries bringing blood to the liver, hepatic portal vein, which is going to be right next to the hepatic artery, from the nutrients in the from the stomach and the intestines, and then you have the hepatic veins carrying the blood out of the liver. That's just the passage of blood. This reflects the passage of bile, how bile gets out of the liver and meets up with the gallbladder. You have the right and left hepatic ducts coming from the liver. The liver makes the bile, the gallbladder stores the bile. It joins to become what's called the common hepatic duct. The common hepatic duct. Common hepatic duct is that one right there. That is going to join with the cystic duct, which is attached to the gallbladder, and then together they're all going to empty that bile into the common bile duct, or simply the bile duct. And this is what's going to take us into the duodenum. Okay? So all that I've described there in green are all the passages right before we get to that common bile duct. All right, back to this. We take a lobule. You'll notice it has 6 corners. At each corner, there are 3 things that exist there. Those 3 things together, we call them the portal triad. The portal triad. There are 3 things in every single corner. So these are the possible things. Those are the 3 things. And by the way, histologically in lab, you do not need to identify this because they're very hard to find. What you should know for lab, you better find that central vein. You better know the hepatocytes and the fact that one group of it is called a lobule. Okay, what makes the 3? Well, you have to have a branch of the hepatic artery proper. That's the one that brings oxygen-rich blood into the liver as if it were just any other systemic organ. You have to have a branch of the hepatic portal vein coming from the stomach and intestines. Lastly, you have to have a piece of a duct that will carry the bile. We're going to call that the bile duct. Why is there no branch of the hepatic vein in that trio? Why is there no branch of the hepatic vein? What was the difference between the hepatic portal vein and the hepatic vein in terms of direction? What do you think, Glenn?
That was completely different from the other things. The vein is only directed to the inferior vein cava at that point.
Exactly. The hepatic vein is only directed toward the inferior vena cava. Where are we with respect to the inferior vena cava? We are far away from it. So I'm going to show you, just by kind of tracing it out, where blood is actually going to flow. Do you see all of these plates of hepatocytes that are there? You have these spaces in between them. Those are called liver sinusoids. So blood comes in at every single corner of that hexagon, and it's going to be directed in this way. That's why there is no branch of the hepatic vein here. Why? The hepatic vein doesn't become the hepatic vein until we're leaving the central vein. So in other words, you have to come away from the liver and toward the inferior vena cava. Okay? Colton, you were going to say something?
I was gonna say, they answered it basically. I was gonna say the same thing.
Okay, cool. All right. But does that make sense? Okay? Blood is going to be going through here. This is the blood that just came from the stomach and intestines. This is the blood that just came from the hepatic portal vein. We're gonna be sending blood through here. That same blood is going to be going between those hepatocytes and emptying or draining into the central vein. That central vein will lead to the hepatic veins, and that will lead to the inferior vena cava. And it's all coming in from each corner of that lobule, okay? So that's the liver. Gallbladder, what you should know about it is that it stores bile. It does not make bile. So I just want to emphasize that. It does not make bile, it stores it. It stores it. And so what are the passageways for bile? Okay, well, that's the common hepatic duct right there. That's the bile passageway that would have come from the liver. This is the bile passageway that would have come from the gallbladder. They are going to meet together, and they are going to become the bile duct, and that's how we're going to empty bile into the duodenum. Right? If anybody's ever heard of gallstones, what gallstones are, that's crystallized cholesterol, typically because there is too much cholesterol that has accumulated, that has not been metabolized properly by the liver. Too much cholesterol or too much bile salt, which is an essential part of the bile that is required in order for bile to emulsify fat. You don't need to know that much more other than what is on here. And then usually when somebody suffers from a gallstone, from a blockage from a gallstone, they don't experience it, the discomfort really, until after they've eaten, especially if it's been just a fatty meal. Okay, if they've had a high fat meal, that's really when we need to get the bile, okay? And that's when they are going to feel the most uncomfortable and feel the most pain. All right, so gallbladder, liver, got that, okay? This one is just talking about the small intestine secreting mucus and enzymes. And so the enzymes that we are discussing here are the ones that are on this side, just as a review, okay? If you are doing proteins, you need to include this. If you're doing lipids, you need to include this, okay? What do you need to include if you are doing carbohydrates? Give me 3. And all it is just go to your lecture and just name them off to me. What are they?
Maltose. Lactose.
And?
Lactose.
Lactase. These are the enzymes that break down the substrates. The substrates, so the enzymes end in ASE. The substrates end in what? OSE. So make sure that you watch how you're spelling it. Maltase breaks down maltose. Sucrase breaks down sucrose. Lactase breaks down, everybody? Lactose. So what does it mean when somebody's lactose intolerant? Are they allergic to lactose? They're not. They just cannot tolerate. What does it mean that they cannot tolerate?
Means it can be broken down.
It can't be broken down. Why can't they break it down? Because they lack lactase. So what do you think when somebody drinks Lactaid? Look at the ingredients. What's in there? Lactase. It's providing to you what you do not make. Okay? And why does it result in, if you're lactose intolerant, why does it result in a lot of discomfort? Because whatever we cannot break down in our small intestine, we've got bacteria in the large intestine to take care of that. And as we know about bacteria, breakdown by the bacteria, they produce a lot of side products in addition to that, many of which may make you feel bloated, okay, or maybe even worse. All right? So that's why. Okay, if we eat a bunch of cruciferous vegetables and we eat a bunch of beans, why is it so uncomfortable if we ate a lot of that in our large intestine? Because we lack the enzymes to be able to break it down. And again, if we lack those enzymes, who's gonna take care of it? Our bacteria are gonna take care of that because they have those enzymes. That makes sense? Okay, all right. Right. Goblet cells are also gonna be hanging out here. Goblet cells are also known as mucus cells. That's okay, and they're going to secrete a nice mucus coat because all the stuff coming from the stomach was real acidic, right? And so we need to be able to protect that surface. Speaking of neutralizing that, we also have duodenal glands that are going to secrete a bicarbonate mucus as well. These, by the way, are not going to be part of your digestive journey. The reason why? They don't digest anything. They just offer protection to the surface. So you do not need to include these guys, but by the time we end up here, any of that digested residue should contain very few nutrients. Of the parts of the small intestine, where are the nutrients mainly absorbed? So remember, there's two separate things. There's digestion, which is breaking down, and there's absorption, which is actually taking up the nutrients into the cells. Where does the majority of absorption of the nutrients happen? Isn't it the jejunum, the center one, the middle one? So by the time we get through the last part of the small intestine, which, by the way, what's the last part of the small intestine? The ileum. Watch how you spell ileum. There is the ileum of the hip bone versus the ileum of the small intestine. They're homophones. Sound the same, spelled differently. Okay? Ileum and ileum. One with two eyes, one with only one eye. Okay, so we're here in the ileum of the small intestine, and now we're about ready to get into the first part, into the cecum. Okay, so what's going on in the large intestine? There is still going to be a little bit of digestion, but who's the one that's performing any of the digestion if we don't have enzymes for it? A lot of what?
Bacteria.
A lot of bacteria. A lot of bacteria, a lot of gut bacteria. Okay, what are the main functions of the large intestine? Okay, absorbing water and electrolytes. Electrolytes are not the same as nutrients. So nutrients, like the big macronutrients, we should have already taken care of all of that. So all we need to do is bring our chyme into that area, which is no longer going to be chyme anymore. Chyme is going to be, water will be removed from that, electrolytes will be removed from that, so that finally we end up something kind of semi-solid. We're going from about half of a liter of chyme, and we're taking it down to about 150 milliliters left of a semi-solid mass, and we're gonna now call that feces. Whatever is left over, all right? That feces ends up getting pushed toward the rectum a few times a day. Typically, when it's gonna be pushed, when there's a big push for that feces, is after you've had a meal. Because there are some neural inputs or some neural circuits that are responsible just for digestion and to stimulate the movement of the GI tract. You need to be eating something or prepared to eat something, okay? And so that's usually what's gonna happen. And peristalsis is happening throughout, okay? So starting with the esophagus, there's peristalsis. The stomach, not a lot of peristalsis because we're doing mostly mixing. The small intestine, a ton of peristalsis. And then finally the large intestine, more peristalsis. Peristalsis is literally propelling the food forward. Propelling the food forward, moving it along, moving it along. That's peristalsis. All right, gross anatomy of the large intestine. This we went in lab, went over in lab. The first part, of course, is the cecum, okay? I'm going to actually close this right now. I want you guys to imagine it. From the ileum, we are going into the cecum. Okay, watch my hand, I'm gonna go ahead and trace it, and I want you to name me what are those parts?
Colon.
Ascending colon,
Transverse. Descending. Sigmoid.
perfect, very good, we can move on. Okay, we're finally in the back. So the transition of tissue, okay, what are we talking about with the transition of tissue here? This is something we mentioned in lab. What was significant about the rectoanal canal?
Oh.
Stratified squamous. Okay, so from what to what? Yes, there's stratified squamous, but we're talking about a transition. So you gotta give me two tissue types. What is changing to what? What did we start out with? Think about what's closer to the outside. If you're closer to the outside, I'm gonna try to get some answers from this corner. Okay? If you are going to transition to the outside, what's more appropriate? Stratified squamous or the other thing? You're going closer to the outside. So stratified squamous, is that for the rectum or is that for the anal canal? Which one is closer to the outside? Or which one, the rectum or the anus? Which one is closer to the outside?
Anus.
The anus. Who's gonna have stratified squamous?
Anus.
What does the rectum have? The
Simple
rectum is going to be
columnar.
just like the ileum,
Simple columnar.
okay? Simple columnar. So what's the transition, everybody, from? Simple columnar to stratified squamous. Can you name me one more little thing with the rectum that made it different from the anal canal? There was also something there in the submucosa, and there was like a ton of it.
This.
Both of them will have muscle. They've got these additional exocrine glands that are in there that do not exist in the anal canal. Mucus cells, a ton of mucus cells. That's how you can tell generally large intestine and the rectum. You gotta have a lot of mucus cells, okay? And that's something that the rectum has in common with the large intestine. The mucus cells. And then once you get to the anal canal in that histology, the mucus cells pretty much all disappear. Why? Because now you are getting ready to go out to the outside, okay? What is the function of the rectum then? The function of the rectum is to store the fecal matter. That's it. And then we're now in the anal canal. There's the internal anal sphincter and there's the external anal sphincter. One of them is involuntarily controlled, the other one is voluntarily controlled. So what is the type of muscle for the one that is involuntarily controlled? Smooth, which means the one that is voluntarily controlled? Skeletal, very good. We're gonna see the same thing when it comes to the urethra. There is going to be an internal one that is involuntarily controlled and an external one that is voluntarily controlled. All right. Okay, I'm gonna give you guys a short break, 3 minutes. A 3-minute mental break, it's your power nap for 3 minutes, and that's perfectly fine.